Okay, let's unpack this. Today, we're doing a deep dive into the vast and pretty fascinating world of cloud services.
hmm
We're looking across the three major players, AWS, Google Cloud, and Azure. And we're drawing from a really extensive stack of source material here. Think certification exams covering everything from, AI practitioner, solutions architect, developer, data engineer, right up to machine learning engineer. So our mission for you listening in is basically to give you a shortcut to being well-informed. We'll distill how these cloud giants tackle common tech challenges, things like application deployment, managing data, and of course, artificial intelligence. We're aiming for some surprising facts, maybe, and definitely those aha moments that spark real curiosity.
Yeah, and what's truly fascinating here, I think, is that while the core technical problems they're solving are often strikingly similar,
Right.
the unique nuances in their solutions, the way they approach it, can really optimize for specific needs. It's less about picking an outright winner
Mm,
and more about finding the perfect fit for your particular challenge.
absolutely. So where do we begin? Let's start right at the foundation. How do these clouds help you run your applications? From the raw power end of things to the more hands-off simplicity. So starting with infrastructure as a service, or IA,
IaaS, yeah.
this is where you get the most granular control, right?
Yeah.
Allowing you direct management of the operating system, basically, virtual machines.
Exactly. VMs.
So on AWS, you're looking at EC2 instances.
EC2, the classic.
Google Cloud offers Compute Engine. And they've got a really neat feature there, the ability to create reusable custom images from snapshots.
Oh, yeah, that's super handy.
Like you take a perfect snapshot of your ideal server setup,
And then you can just stamp out dozens or hundreds of identical copies. Really efficient.
and over on Azure, it's Azure Virtual Machines, VMs,
Right. And they also include VM scale sets to automate deployment and removal.
making it easier to grow or shrink your fleet as needed.
If we connect this to the biggest picture, IaaS gives you the most control, which for some teams, that's exactly what they need, that ability to tweak every single setting.
Sure.
But with that power comes the most responsibility. You're managing everything from the OS up. It's definitely a trade-off.
So if you'd rather focus purely on your code, maybe let the cloud handle more of that underlying infrastructure. Platform as a service, PaaS, that's your go-to.
That's the idea. PaaS abstracts away the underlying servers, the storage.
Lets you concentrate on the application logic.
Exactly. So Google Cloud's App Engine, for instance, is really designed for scalable web applications with minimal infra management.
And a key detail there, especially for cost efficiency, is its ability to actually scale down to 0 instances
Right.
in the standard environment.
Yeah, when it's idle.
Yeah.
That's huge.
Imagine only paying pennies for a service that's barely being used.
And it also supports handy features like traffic splitting.
Oh, yeah.
So you can direct, say, just 1% of users to a new version. Really safe, gradual rollouts.
Nice. And Azure App Service. Similar idea.
Yeah, supports web apps, containers too. Integrates nicely with container registries.
But if you want even less to manage, or maybe you need ultimate flexibility, that's where serverless and containers really shine, isn't it?
Absolutely. Function as a service, face, container as a service, ConS.
Right. So AWS Lambda, that's the classic example of event-driven compute.
Different.
Like, say you've got images uploading to S3 and you need to resize them instantly. Lambda's perfect for that, triggered directly by those S3 events.
Processes files on the fly.
And for developers, a small but vital detail is that 512 millibit ConS DLP directory. It's available for temporary files during function execution.
Right, so you don't always need external storage for quick tasks.
Exactly. Plus, Lambda can use SQS or SNS for dead letter queues, DLQs.
Safety net.
Yeah, automatically capturing failed invocations so you can analyze what went wrong.
Smart. Google Cloud Functions are natively triggered by cloud storage events too for that highly responsive event-driven code.
And Azure Functions.
They support timer triggers with CRON expressions for scheduled tasks like running something every hour.
Ah, okay.
And blob triggers for reactive processing when files are created. Again, automating tasks, reacting to data without you managing servers.
And then for orchestrating more complex applications, we get into the managed Kubernetes offerings.
Right, like Google Kubernetes Engine, GKE.
And Azure Kubernetes Service, AKS.
Yep. Fully managed Kubernetes, providing automatic scaling, self-healing for your containerized apps. Takes a lot of the operational burden off.
Exactly. But okay, if you want the best of both worlds containers, and serverless scale to 0 Google Cloud Run is a particular standout here.
It really is.
It dramatically minimizes cost when there's no traffic. That's not just a gimmick. It fundamentally shifts the cost model for workloads that aren't constantly busy.
Totally. Though you can set a minimum number of instances if you need to prevent those cold starts.
Right, for latency-sensitive stuff. A strategic choice you make.
Mm-hmm. And then you've also got AWS Fargate and Azure Container Instances, ACI.
What's their angle?
They provide serverless compute for containers too, but maybe simplified deployment for less complex workloads compared to full Kubernetes.
Gotcha.
This highlights a really crucial aspect, I think, for those bursty workloads where cost efficiency is absolutely paramount.
Yeah.
Services like Cloud Run or Fargate become incredibly powerful. That ability to scale down to zero when not in use, that can lead to significant savings, especially for, startups or side projects.
Makes perfect sense.
Cool.
Okay, so once your applications are up and running, how do they communicate securely and efficiently? That brings us to the crucial world of networking and connectivity.
Super important.
For private connectivity, keeping traffic off the public internet, AWS has Private Link.
Right. Secure, private access to AWS services.
And Google Cloud.
They have private Google access and private link, similar idea, allowing internal access to Google APIs and services without hitting the public internet.
Okay.
And Google also offers serverless VPC access specifically for App Engine, letting it connect directly into resources inside your virtual private cloud, your VPC.
And Azure.
Azure provides VPN gateway for secure connections back to your own premises over the public internet, but encrypted.
And for the really high-speed, dedicated private lines.
You've got AWS Direct Connect.
Used to be Express Route, right. Oh, wait, no, Azure is Express Route. AWS is Direct Connect.
Right, Azure is Express Route, AWS Direct Connect. And Google Cloud has dedicated interconnect or partner interconnect. Big pipes, basically.
Okay, now, managing the traffic itself.
Yeah.
Load balancing.
Yeah, tracking users.
The AWS Application Load Balancer, ALB, integrates with AWS API Gateway for advanced stuff like Canary releases.
Right, you mentioned that. Shifting maybe 10% of traffic to a new version.
Exactly. Mitigating risk when you roll out new features.
Smart. Azure Front Door is interesting, too. It's a global HTTPS load balancer.
Global.
Yeah, with SSL offload right at the edge and application acceleration. It's especially useful if you have users all over the world. It routes them to the nearest edge location for speed, but can also ensure data residency, like keeping German user data within EU boundaries, even if the main app is elsewhere.
Ah, clever. And Google Cloud?
The standard way there is usually the Google Cloud HTTPS load balancer, often used with Ingress for GKE applications you want to expose publicly with HTTPS.
Okay.
What really stands out with some of these, like Azure Front Door, is how they unify things. Global traffic management, SSL termination, even web application firewall wavelength capabilities. All in one service for complex, geo-distributed apps.
It takes a load off the developers.
It does, though it adds another layer you need to understand and manage, of course.
True. And then for firewalls, more granular security.
Azure Firewall is a managed, centralized service, good for filtering traffic across multiple virtual networks, even subscriptions.
Central control.
Yep. And then both Azure Network Security Groups, NSGs, and Google Cloud Firewall rules give you that really granular control over traffic flow to and from your resources. You decide exactly who talks to what.
All right, let's dive into data. The lifeblood, maybe the biggest challenge for any modern application. How do these cloud providers handle storing, processing, and making sense of your information?
Yeah, data's huge. Let's start with relational databases, the familiar SQL world.
Okay. AWS RDS. It has that RDS proxy feature.
Yes, that's really useful for managing database connections efficiently, especially from high-volume AWS Lambda invocations.
Right, you mentioned Lambdas can overwhelm a database with connections.
Exactly. RDS proxy acts like a smart bouncer, pooling those connections, so your Lambdas can burst without breaking the database.
Nice. And RDS also offers multi-AZDB clusters for automatic failover.
Right, under 40 seconds typically. Pretty impressive resilience, plus read scalability through a dedicated reader endpoint.
Okay, Google Cloud SQL supporting PostgreSQL and MySQL. What's its HA story?
High availability there uses synchronous replication across zones, ensures automatic failover if a whole zone goes down. And automated backups can be kept for up to a year, 365 days. Plus, their Query Insights dashboard is really slick for troubleshooting database performance issues easily.
And Azure?
They offer highly available options like Azure SQL Database Business Critical tier or the Azure Database for MySQL Flexible Server, especially the Burst Stable tier for cost optimization. Both give you zone resilience.
Good options. Okay, moving to NoSQL. AWS DynamoDB has that time-to-live TTL feature.
Yeah, TTL is great. It automatically removes expired items based on a timestamp attribute you set, simplifies data retention policies a lot.
No manual cleanup scripts needed.
Exactly. Azure Cosmos DB is another big player here. It supports multi-region writes and handles conflict resolution automatically.
Ah, so ideal for globally distributed applications needing high availability everywhere.
Precisely. And its change feed lets you react in real time to document updates, powering reactive apps.
And Google Cloud Bigtable.
Bigtable is designed for massive scale, really low latency NoSQL, optimized for things like real-time ingestion, time series data. But it performs best, and this is key, with high cardinality row key prefixes.
Yeah, meaning?
Meaning you need to design your keys carefully so data gets spread out evenly. Think distributing packages to lots of different mailboxes instead of jamming them all into one. Avoids performance bottlenecks called hot partitions.
Gotcha. Design matters there.
It really does. And that's a fantastic point, actually. Choosing the right data store, it isn't about finding the one-size-fits-all best option.
No.
It's about deeply understanding your specific access patterns, your scale needs. For someone listening who's just starting a new project, where's maybe the biggest gotcha when picking between, say, a relational DB and something like DynamoDB?
Ooh, good question. I think the biggest gotcha often boils down to data relationships. If your data is highly interconnected, lots of complex joins needed. SQL is probably your comfort zone and maybe the right choice.
Yeah.
But if you have more independent documents or simple key-value pairs, and blazing fast, massive scale is the absolute priority.
Then NoSQL starts to look really attractive.
Exactly. You're often sacrificing some of that relational flexibility, that easy joining, for extreme performance and scalability. It's a trade-off.
Makes sense.
Okay, what about data warehousing and analytics? Processing huge amounts of data.
Right. Google Cloud BigQuery is a major player here. Serverless, multi-cloud data warehouse.
Designed for petabyte-scale analytics using standard SQL.
Yep. And its cost-effectiveness is a standout, achieved through smart design like partitioning tables maybe by date or timestamp.
Or clustering them, say, by a tracking ID for better query efficiency.
Exactly. Less data scanned means lower costs and faster queries. Materialized views can also pre-compute results for common queries, speeding up dashboards.
And they have Analytics Hub for securely sharing data between teams.
Yeah. AWS Athena is another interesting one, serverless query service for data that's just sitting in S3.
So you don't have to move the data first.
Nope. Imagine petabytes in S3, and you just query it directly with standard SQL. That's the magic of Athena.
Powerful.
Yeah.
And Azure.
Azure Synapse Analytics and Databricks provide integrated Spark environments. Really good for large-scale ETL extract, transform, load, and more advanced analytics.
Gotcha. And caching for speeding things up.
Crucial for performance. AWS has Elasticache, which supports Redis OSS, and also DynamoDB Accelerator DAX.
What do they do?
They're in-memory caches, designed to /read latency for RDS and DynamoDB respectively. Basically, they speed up data access and take load off your main databases.
By Google Cloud.
Memory Store offers sub-millisecond access for caching, improving response times for applications and dashboards.
Okay, now data processing and ETL itself, moving and transforming data.
Google Cloud Dataflow is a fully managed service for both streaming and batch processing.
Both?
Yeah. It includes powerful windowed aggregations like tumbling windows for getting hourly aggregates from a stream, and it supports custom Apache Beam connectors if you need to process proprietary data formats.
Flexible. What about extracting data from, say, documents?
AWS Textract is great for that. Automates high-accuracy OCR optical character recognition on documents, tables, forms, ideal for processing receipts, invoices at scale.
Useful. And understanding text.
AWS Comprehend uses machine learning to pull insights from unstructured text. Think sentiment analysis from customer feedback or identifying key entities mentioned.
And data privacy. Handling sensitive info.
Google Cloud's data loss prevention, or DLP, API is critical here. It can de-identify sensitive data PII by masking or tokenizing it before it gets stored or processed. Super important for compliance.
Absolutely. Okay, messaging and eventing. Connecting different parts of a system.
AWS has SQS FIFO queues and SNS.
FIFO.
First in, first out. Ensures strict ordering and deduplication. Crucial for things like financial transactions where order absolutely matters.
Right, and SNS.
Simple notification service, flexible fan-out notifications, publish once, deliver to many subscribers.
Google Cloud PubSub.
That's a high-volume streaming message bus. Guarantees at least once message delivery.
At least once.
Meaning, you might get the same message more than once, occasionally. So you must implement idempotent logic in your message handlers.
Ah, so your processing code needs to be safe to run multiple times with the same input without causing issues.
Exactly. That's a key best practice for robust systems using PubSub. It also supports dead letter topics like Lambda for routing failed messages from monitoring.
In Azure.
Azure Event Hubs are really engineered to ingest and buffer massive volumes of streaming events. Think telemetry data from thousands of IoT devices, buffering it before it hits downstream processing.
Wow. So, okay, putting it all together for data pipelines,
Yeah.
it means you have incredible tools, right?
Absolutely. But orchestrating the right tool for each stage of your data's journey, that's the key. It's about understanding the flow and picking the best fit.
Okay, now here's where it gets really revolutionary, I think. Artificial intelligence and machine learning.
Definitely. All three clouds are pushing hard here, especially with generative AI.
So generative AI at its core, it's models and algorithms that can create brand new content.
Yeah, text, images, audio, based on patterns learned from huge amounts of existing data.
And large language models, LLMs, are key to this.
They are trained on vast, diverse data sets, giving them broad language and context understanding, and a crucial detail for anyone using them. LLM inference costs are primarily driven by the number of tokens consumed.
Tokens meaning roughly words or parts of words.
Basically, yeah.
Yeah.
So optimizing your prompts, making them concise and effective can actually save you a lot of money.
Interesting. And prompt engineering itself is critical.
Hugely. Techniques like chain of thought prompting that guides the LLM to break down complex problems into smaller logical steps really improves reasoning.
You can tweak parameters like top P and top K.
Right, to control the diversity and probability of the generated tokens, fine-tuning the AI's creativity versus predictability.
Now, you hear a lot about hallucinations. How do you combat that?
Grounding is the key technique, also called retrieval augmented generation, or RAG.
RAG.
It ties the LLM's responses back to verified source documents, prevents it from making stuff up, and ensures accuracy, maybe alignment with company policies.
Like a chatbot using only the latest product documentation you provided.
Exactly. And for the hardware side, AWS offers specialized chips like Trainium for high-performance training.
And Inferentia for cost-effective inference, especially for generative AI.
Yeah, purpose-built silicon for AI workloads.
Google Cloud also has some impressive pre-built tools in this space. Notebook LM.
Yeah, it's like an interactive AI-powered notebook. Explore data, summarize docs, ask questions against uploaded documents. Kind of an AI research assistant.
Cool. And Vertex AI Agent Builder.
That's a low-code service specifically for building and deploying production-grade AI chatbots.
Makes it more accessible.
Definitely. And Google Agent Spaces for building custom AI assistants that can query multiple backend systems, integrate sales, inventory, marketing data, maybe.
Yeah. And Imogen.
That's their text-to-image model, capable of generating photorealistic images from text prompts.
Okay, moving to the broader machine learning platforms.
Yeah.
AWS SageMaker.
SageMaker is a big one. It has Jumpstart, which is a no-code catalog of pre-built models, one-click deployment, evaluation, great for getting started fast.
And SageMaker Clarify.
Clarify is crucial. It helps detect model bias and explain predictions before you deploy. Offers pre- and post-training bias detection, feature importance explainability, really vital for responsible AI.
Absolutely. And asynchronous inference.
That's best suited for specific use cases. Large payloads up to a gigabyte and long processing times up to an hour. Think genomic analysis.
Gotcha. Google Cloud's end-to-end platform is Vertex AI.
Correct. Vertex AI Workbench is their Jupyter-like environment for interactive prototyping.
Familiar for data scientists.
Exactly. Vertex AI pipelines help schedule recurring data pipelines and ML retraining jobs, handling dependencies, automates your MLOps workflow.
And explainability. Understanding why a model predicts something.
Vertex Explainable AI provides feature-level attributions for individual predictions, critical for trust and debugging.
And monitoring models once they're live.
Vertex AI model monitoring detects prediction drift and skew, triggering alerts so you know when to retrain.
Keeps models accurate over time.
Yep. And Vertex AI Feature Store serves real-time user features for low-latency online predictions, like personalized recommendations.
And you can control access tightly.
Yeah, IAM conditions on Vertex AI resources can enforce dataset access policies. Ensures models are trained only on approved data.
What about AutoML? Building models without deep ML expertise.
Google Cloud AutoML is powerful here. Build custom models on structured data with AutoML tables, images with AutoML vision, text with AutoML natural language. enables rapid iteration, minimizes cost, lowers the barrier to entry.
A game changer for many businesses.
Truly. And transfer learning is another key technique.
Leveraging existing models.
Exactly. Highly efficient, especially if you only have a small number of labeled examples, maybe just 1,000 for image classification. Saves immense training time and data needs.
Smart. And reinforcement learning.
That's used for training agents through trial and error, based on reward signals. Optimizing warehouse operations to reduce costs is a good example.
Learning by doing. Finally, AWS Cloud Queue Developer.
Yeah, that's interesting. Provides natural language answers to AWS account-specific questions, especially about costs. Helps understand and manage your cloud infrastructure using plain English. Democratizing cloud management.
Really interesting.
You know, if we connect this to the bigger picture, the goal is increasingly about empowering everyone, even users without deep coding skills, to harness AI.
Right.
And these tools are evolving incredibly fast to make that possible, turning complex AI concepts into practical, accessible solutions for everyday business problems.
Okay. Building cool stuff in the cloud is exciting, but it comes with critical responsibilities, right?
Yeah.
Keeping data secure, meeting compliance, and of course, managing costs.
Absolutely fundamental.
So identity and access management, IAM, secrets management. The golden rule is the principle of least privilege.
Always. Grant only the absolute minimum necessary permissions, like specific DynamoDB actions, or just the BigQuery data viewer role for read-only access. Nothing more.
Makes sense. AWS Secrets Manager helps here.
Yeah, it securely stores and, importantly, automatically rotates database credentials and other secrets, gets them out of your code, which is a huge security win.
Azure Key Vault.
Similar idea. Centralized service for managing secrets, certificates, encryption keys, integrates tightly with managed identities.
Managed identities.
Yeah, they let Azure applications authenticate to services like Key Vault using Azure AD without needing any credentials stored in the application code or config. Secretless access.
Very cool. Google Cloud Secret Manager.
Provides secure, auditable access to secrets too, with native integration and fine-grained IAM controls.
And user management. Sign up. Sign in.
AWS Cognito fully manages user sign-up, sign-in, and federation with social identity providers like Google or Facebook.
Takes that burden off.
Yep. And Google Cloud Identity helps sync users from existing systems like Active Directory and enables external single sign-on via SAML.
Okay. Encryption and data protection. Encryption at rest. AWS S3.
S3 offers server-side encryption with AWS KMS keys, SSE KMS, and it supports automatic key rotation, which often helps meet compliance requirements.
Plus MFA delete.
Yeah, multi-factor authentication delete on S3 buckets adds an extra layer of protection against accidental deletion, a really good guardrail.
Google Cloud Storage. What's their story for compliance? Like Worm.
Object lock with compliance mode and locked retention policies. Ensures write once, read many behavior, prevents deletion or modification until the retention period ends, even by administrators. Critical for regulated industries.
And customer managed encryption keys, CMAK.
Yep, Google Cloud supports CMEK, giving customers granular control over the encryption keys used for their data.
Azure Blob Storage.
Similar features. Time-based retention policies, version-level immutability, enforce Worm. And they have point-in-time restore, letting you revert an entire storage account back to a previous state within a certain window.
Handy for recovery.
Very. Azure Data Lake Storage Gen 2, ADLS Gen 2 also supports per-user encryption keys. And back in Google Cloud, Cloud SQL backups can be encrypted with CMAC too for enhanced control.
And handling sensitive data within data sets. Redaction.
That Google Cloud DLP API we mentioned earlier can mask or tokenize sensitive data, PII, before it lands in something like BigQuery. Crucial for privacy compliance. You know, this really raises an important question about balancing control with agility.
How so?
Well, while all these robust security features are absolutely paramount, a well-designed governance strategy needs to make sure these guardrails don't accidentally become a blocker to innovation.
Right. You want to enable secure development, not stop development.
Exactly. It's about finding that balance.
So for governance and compliance enforcement, how do you set those rules, Azure policy?
Azure policy is super powerful for enforcing organizational standards. You can set rules like requiring specific tags, maybe cost center and environment, on all resources.
Or restrict things.
Yeah, restrict the use of external IP addresses on VMs or limit how many VMs can be in a single resource group. And you can apply these policies at different levels: management groups, subscriptions, resource groups. Very flexible.
AWS has service control policies, SCPs.
Right, used within AWS organizations to set guardrails across multiple accounts. A classic example is denying an action like ec2.go, create volume if the ec2 encrypted flag isn't set to true, enforces encryption defaults everywhere.
Smart. Google Cloud's organization policy.
Similar concept. One useful policy is domain-restricted sharing, which can restrict where resources can be created geographically, say, U.S. only to meet data residency requirements.
And binary authorization in Google Cloud.
That's focused on container security. Ensures only signed, verified container images can actually be deployed to GKE. Enforces supply chain security.
Okay, and let's not forget the bottom line, cost optimization.
Always important.
The cloud offers incredible flexibility to save money, if you know where to look, right? It's about smart choices.
Exactly. Not just throwing compute power at problems.
So elasticity is fundamental.
The inherent cloud benefit. Automatically adjusting resources, scaling up or down to match demand. Avoids paying for idle, over-provisioned resources.
Spot instances in AWS, preemptible VMs in Google Cloud.
Huge cost savers. Can be like 90% off the on-demand price for Spot.
Wow, but they can be interrupted.
Yeah. That's the catch. Best for interruptible, stateless, or fault-tolerant workloads. Think batch processing, some types of rendering or analysis, not for your main database server.
Makes sense. Google Cloud Run, we mentioned its scale to 0.
A prime example of cost optimization. You literally only pay when your application is actively serving requests. Scales down to nothing when idle.
BigQuery cost management.
Partitioning and clustering tables, like we talked about, significantly reduces query costs by limiting the data scanned. Materialized views help too. Pre-computing results.
Azure cost management.
Available for pay-as-you-go subscriptions to track and manage spending. Get visibility into where the money's going.
And application insights adaptive sampling in Azure.
That's clever. It dynamically adjusts the volume of telemetry data sent from high-traffic applications. Reduces costs while trying to maintain the important insights.
Smart balancing act. Okay, finally, the practical side. Keeping everything running smoothly, diagnosing issues, continuously improving. Operations.
Day-to-day reality. Monitoring and alerting are key.
AWS CloudWatch.
Lets you create metric filters from logs, maybe detect specific application error patterns, and set up alarms to send SNS notifications in real time. Proactive responses.
Azure Monitor.
That centrally collects and analyzes logs and metrics from Azure, even on-premises resources. Feeds them into log analytics workspaces for unified analysis.
Google Cloud Monitoring.
Provides predefined dashboards, lets you create custom log-based metrics to trigger alerts automatically, like getting notified about permission denied errors immediately.
Azure Application Insights.
Provides deep application telemetry, and has that adaptive sampling feature we just mentioned to help manage costs in high-traffic scenarios.
And Google Cloud Logging.
Supports using SQL queries to analyze your application logs. Can be really powerful for digging into complex issues. What's truly powerful about all these comprehensive monitoring suites, I think, is how they enable proactive problem solving.
Moving beyond just reacting.
Exactly. It's a fundamental shift from reactive firefighting towards predictive maintenance, catching issues before they impact your users.
For troubleshooting specific things, Google Cloud Query Insights.
Yeah, specifically built for diagnosing and improving database query performance in Cloud SQL. Really focuses on that one area.
Cloud Trace in Google Cloud.
That provides detailed request latency analysis. Great for identifying performance bottlenecks across distributed systems, seeing where the time is spent.
And if you're using Kubernetes and a pod is stuck.
Checking the pod events is usually the most direct way to diagnose why it's stuck in, say, a pending state. Often reveals issues like insufficient CPU or memory resources.
Okay. Deployment and CI/CD best practices. Infrastructure as code, IAC.
Absolutely foundational. Using tools like Google Cloud Deployment Manager or Terraform with Cloud Build. Define your infrastructure in code.
What are the benefits?
Consistency, version control, automated deployments. Makes everything repeatable and less error-prone.
Rolling updates.
In GKE, doing a kubectl apply with a new image version typically performs a rolling update, minimizing downtime. And App Engine's traffic splitting allows those gradual percentage-based rollouts we talked about. Full control over release risk.
API versioning.
Crucial if you have customers relying on your APIs. Adopt a strategy like incrementing the version number for any backward incompatible changes to avoid breaking things for them.
Good practice. And database schema changes in production.
Zero downtime schema changes. An essential best practice in production Cloud SQL environments or any production database, really, to avoid disrupting your application during updates.
Needs careful planning.
Definitely.
Lastly, data migration strategies. Getting data into the cloud.
Google Cloud's Database Migration Service, DMS, is interesting, supports continuous replication from on-premises databases like PostgreSQL and MySQL to Cloud SQL.
Continuous replication.
Yeah, minimizes the downtime needed during the final migration cutover, keeps syncing until you're ready to switch.
What about massive amounts of data? Too big for the internet.
That's where physical appliances come in. AWS Snowball Google Cloud Transfer Appliance.
You ship a box.
But basically, yeah, they send you a rugged device, you load your data onto it, ship it back, and they upload it directly into the cloud. Can move huge amounts, like 700 TB, in under a month, much faster than over the network.
Wow. And for large online transfers.
AWS Data Sync is designed for large, online, and potentially ongoing data transfers between on-premises systems and AWS.
Okay. It's clear that while the cloud offers just immense power and flexibility, mastering these operational nuances, the monitoring, the deployment, the migration, that's what truly unlocks their potential, isn't it?
Absolutely. It's where the rubber meets the road.
So what does this all mean for you, the listener? I think it means that really understanding the unique strengths, the different approaches, the specific services of each cloud provider, AWS, Google Cloud, Azure, it allows you to make informed, optimized decisions. Decisions tailored to your specific application or your data or your AI and MLA needs.
Exactly.
It's really about knowing which tool to pick for the job at hand, rather than just defaulting to a one-size-fits-all approach.
Well said. And maybe this raises one final important question for people to think about. As these cloud services become increasingly specialized, increasingly integrated,
Yeah.
how will organizations effectively balance the benefits of multi-cloud flexibility, using the best tool from each cloud, perhaps, with the inherent operational complexity that comes from managing these diverse ecosystems?
That's a great point. It's a continuous balancing act, isn't it? Flexibility versus complexity.
It really is something to keep in mind.
Definitely food for thought. We hope this deep dive has given you some surprising facts, maybe some invaluable insights. Keep exploring the cloud, keep learning, and we'll catch you on the next deep dive.